Good day, everyone. We are very fortunate to be selected as one of the presenter at the International Postgraduate Conference on Mechanical Engineering, organized by the Faculty of Mechanical Engineering Technology, University Malaysia, Pahang. I'm Silbalan Kaniappan, your presenter here from University Technology Petronas. I'm going to talk about this experimental analysis on the characteristic of empty fruit punch, palm kernel shell, coconut shell, and dry sass for biomass boiler fuel. So, without further ado, let us just look at the outlook of today's presentations. So I'm going to talk about the introductions, followed by Malaysian biomass power plant, potential agricultural residues, type of biomass, and method we use in this paper, and followed by the conclusion with a brief review on the findings that we have found from this paper. Electricity is one of the fundamental and core form of energy, and it's one of the fastest, quickest developing medium on the planet, where the usage of electricity is the way of economic development as well as the living standard among people. Fossil fuel has been extensively used for the production of energy, which eventually replenish soon in the next 40 to 60 years. The conventional fossil fuel dependency caused high environmental impact, resulted in greenhouse gas emissions and environmental pollutions, which could potentially lead to global warming and human health deterioration such as skin cancer and respiratory related disease. Several countries have been actively looking for other energy solutions, which is much cleaner and environmental friendly. Biomass has been identified as cleaner and environmentally safely. As I said before, biomass is a desirable living matters such as waste, product, residues from agriculture, forestry, and industry, and household waste. Biomass is a cleaner alternative energy source which can be used in both thermochemical and biochemical ways. Furthermore, biomass is called carbon neutral by scholars due to the fact that the plant captures carbon dioxide during growing stage and repel the same amount of carbon dioxide when it was incinerated. As among the nations with abundant biomass availability, Malaysia is yet to be appropriately utilize its biomass in the region. As table here shows most of the plant which uses single biomass residues, and here it uses most of this power plant uses palm based residues. There are potential agricultural residues which, according to Zafar, Malaysia prime agrarian crop comes from various types of plants such as coconut, cocoa, rice, oil palm, and rubbers. And according to Griffin and Nur Hidayati, they found that 17 million tons of biomass waste per year discovered in Malaysia, whereby 77% palm oil waste and 8.2% forestry byproduct, rice residue 9.1%, and 5.7% others. There are types of biomass. As a prime example of solid biomass is wood and bark and residues from lumber mills and sawdust. Whereas liquid biomass comes from animal waste, manure and sewage, and vegetable oil. Whereas gas biomass can be also generated through liquid biofuel through thermochemical and biochemical processes. Biomass structure built with a strong cellulose, semicellulose, and lignin, which is the fundamental component holding the whole structure of the plant. As a methodology, the selection of feedstock has been selected followed by feedstock preparations, and proximate analysis, ultimate analysis, and high weighting value has been conducted as well. An experimental result has been gained through this experiment, followed by discussion, and last but not least, conclusion. Overall, the feedstock has been selected, whereby here is EAB, PKS, ISAS, and coconut shell. All this feedstock has undergone dehydrations, whereby the feedstock were dehydrated using oven at 105 degrees Celsius for 24 hours before ground into powder using mortar, and sieve it to 0.3 to 0.5 mm of the sample, and keep it in an airtight container. From the result, we know that there are 3 decompositions happen through this proximate analysis, whereby desorptions, followed by decompositions and volatilizations. Rysas exhibit the lowest moisture content, accompanied by PKS, coconut shell, and EAB. Percentage of moisture determines the thermochemical efficiency and also cause variations in the drying process. As you can see from this table here, Ti is ignition temperature, Ta1 to Ta3 is multi-step decompositions, followed by Tb, the burnout temperature. From the graphs and also from these illustrations, it is found that the volatile matter of both PKS and EAB exhibits the highest, whereby the higher the volatile matter, the better the ignition would be. Compared to ash content, it has found that ash content in Rysas is quite higher. Ash content, if it's quite high in any type biomass, it can cause some problems in boiler, whereby it can form falling and slagging, and can also cause unprecedented shutdown of the boiler. In Ultima analysis, we have used carbon, hydrogen, nitrogen, sulfur analyzer, whereby the higher the percentage of carbon, hydrogen, oxygen, the better it is compared to the lower percentage of these 3 elements in any fuels. So overall, from these these components that we have used, carbon has been found to be quite higher in coconut shell, followed by PKS, EAB, and Rysas, whereas hydrogen percentage is quite higher in PKS, followed by EAB, coconut shell, and Rysas. Last but not least, oxygen has been found quite high in coconut shell, followed by Rysas, PKS, and EAB. So overall, we can conclude that coconut shell ignites better than any of these fuel. So the content of nitrogen and sulfur has been found very, very little in all these biomass samples. The maximum nitrogen found in coconut shell, which is about 0.71%, whereas maximum sulfur has been found in EAB. Ash and HHV would be in PKS, where ash is quite low and HHV is quite high in PKS. Second will be coconut shell, third will be EAB, and Rysas will be the fourth. Even though EAB has the lowest ash content than coconut shell is still considered as better fuel than EAB in considering other factors such as oxygen, sulfur, and moisture content. Excessive ash could lead to operation interruption and undesirable shutdown, such as lagging, falling, and corrosion, as I said previously in previous slides. As a conclusion, several studies have been conducted on each subject matter of individual biomass materials such as EAB, PKS, Rysas, and coconut shell. However, none of these discuss the correlations or the differences in the combustion system between these 4 biomass samples. In conclusion, lignin fractions with the carbon, hydrogen, oxygen matter the other minor elements sulfur and nitrogen, whereas Rysas is the least favorable fuels. However, with the right mixing ratio of all these fuels, The fuel cost could be reduced. Biomass power plant could be free from dependency on single biomass source availability for energy production. This biomass material can be further enhanced through pre-treatment methods such as torrefications, pyrolysis, and densification processes. Energy density, and also it can also increase the value of the feedstock. Thank you.